While starting the quadratic formula, we studied or we understood how the value of x is obtained just by looking at the coefficients and constants given to you in the question. And if you look at the quadratic formula, this is how it looks. There is something that makes this quadratic look a little unique. This formula looks a little unique, or there is something that this formula can help you understand about what kind of values you're going to get for any equation. What I mean by that is, if you look at this formula, minus b plus minus square root b squared minus 4ac. This square root number, you know, a square root value has some restriction. The value inside a square root cannot be just anything. Like, for example, the value, if you have something like a negative number inside a square root, then you cannot solve it, or you do not have the real answer or a real number value which will satisfy this condition. This square root part that comes in this formula can be used to understand and analyze the nature of roots or the nature of solutions. We use different words for the same value of x, okay? The value of x in a quadratic is called the root. Sometimes we call the zero as well. We also call the solution. So all of this represent the same thing, okay? Now, to find the nature of roots or to find what kind of values we are going to get, we can definitely have a look at something which is inside this root. So what you have inside this root, this expression b squared minus 4ac, this part is now called the discriminant. The part that we have in the formula inside the root, that is called discriminant. What does this discriminant do? What is the purpose of this discriminant? The values of discriminant inside this root can be anything, because depending on what the coefficients of the equation are, we will try to plug in the values. So discriminant here can be different, or I'm just going to take different cases. The first case, I'm saying that the discriminant value here is greater than 0. Greater than 0 means basically positive. So if you get a positive value inside this root, what happens? For a positive root, the square root of 4 can be both plus minus 2. So when you have a positive root, or when the value inside the root is positive, then in that case you get two real and distinct roots. Distinct as in two values will be different. You will get two answers. I've told you how a quadratic can give you a maximum of two values or two zeros, not more than that. It can have one, but it cannot have more than two. So you get exactly two distinct values when the discriminant is positive. Okay, that is case 1. That is the first nature, or in this case, if your discriminant is greater than 0 or positive, that is when you have two real and distinct. Distinct as in the two values you're going to get will be different from each other. That is the first case. Now let's talk about case 2. In that case, I'm assuming the discriminant could sometimes be 0. Discriminant is equal to 0 as in your b squared minus 4ac. Upon solving it, you might get the value exactly 0. So when you get the value exactly 0, what does that mean? You can see if your discriminant is 0, then your quadratic formula just reduces to minus b plus minus square root of 0. Square root of 0 added or subtracted is still 0. So we just get the answer that x has to be equal to minus b by 2a. There is only one answer. So when the real root is present only once, it does not mean there is only one answer here. We call it as the repeated root. Meaning, I know that a quadratic must have two values. So if I'm getting only one value, it means the same value is repeated, or the root is called the repeated root. Now there is a case 3. That is a case when your discriminant is less than 0. Now less than 0 basically means you are getting a negative value. If you get a negative value for the discriminant, then what happens? Your answer just becomes x equals to minus b plus minus square root of negative, which is not possible. It's undefined. So if you are getting this answer as if this part of the solution is undefined, then the whole solution is undefined, because you're adding an undefined term to something. It's not possible to get a defined answer. That should make sense. So if you're using the formula, but if you're using the formula and you just realize that by finding the discriminant, the value of discriminant is less than 0, then in that case there is no real root, as in there is no real value which will be able to satisfy that equation, or there is no 0 for that particular quadratic equation. No real root or no real zeros. You will later on realize that these kind of equation too will be solvable, but for now you really need to know that anything inside a negative or any value that's negative inside a root should not be proceed. I mean, we don't have to proceed further with that because it's not going to give me a real number value. So no real roots. So what do you see? There are three cases. In two of the cases, solution is possible. In one case, the solution is never possible. What is the case when solution is possible? When the discriminant is either greater than or equal to 0. Okay? Both cases will give you answer, will give you the defined values for x. In one case, when it is positive or when it is greater than 0, that is specifically when you get two exact answers. But if the discriminant is 0, the equation becomes much easier to solve and your formula becomes very easy to use. And hence, you just get one answer in that case. So this is called the nature of roots, and this is how discriminant helps you to find the nature of roots. Okay? So d greater than equal to 0 gives you real answer or real solution, while discriminant less than 0 gives you no solution, no real solution. This is the concept of discriminant. I hope this made sense.